Hi, welcome to an Arduino tutorial from Robojax. In this video, I'm going to introduce this Arduino Pro Micro with a chip ATMEGA32U4 with 32 kilobyte of flash and with tons of pens that can be used with the compact size. Let's get started with this. In this tutorial, I'm going to introduce this Pro Micro based on this ATML chip, ATMEGA32U4 Arduino board. This is amazing in terms of capability and size. As you can see, the size is very tiny, but it has all or at least majority of capability of Arduino Uno that you might have used, exception of this ICSP connector and the pin 13. The rest, everything is even better than Arduino Uno. It has built-in USB that you can connect it directly without extra chip. So the USB is on this chip, and majority of operating system recognizes automatically. We get 16 digital pins. We get 9 analog pins. Now let's have a look at the number of pins that we got here. For this Pro Micro, we have total 24 pins, 12 on this side, 12 on this side. But on this side, these 4 pins are used for raw, that is whatever you input here from outside, 12 volts or whatever up to 12 volts. This is ground, the reset. To reset Arduino, you can connect a switch here and connect it to 5 volts and it will reset. And then we have VCC. This VCC is 5 volts. Whatever you enter, let's say 12 volts, it goes to this regulator and you will get 5 volts out if you need it for other purpose. And the rest of these pins here, out of 12, we have 8 here and 8 here on this side. And then we have 2 ground and then analog. As you can see, we have 8 here and 8 here, that is 16. 2 ground is here, and then these 2 are also in out pin. These are for RX and TX. Out of these pins, from here to here, 16 can be used for digital. And for analog, these are labeled as green. These can be used for analog. All of these pins. But out of these pins, with the digital, we have these pins that have been marked with red. These are the pulse width modulation pin here. I will provide you this image so you can refer to it. For SDA and SCL, for the I2C communication, these 2 pins that are labeled here as pin 2 and 3 on this side, these can be used. The module that I have does not have a label here, but these are the pin 2 and 3 that can be used for pulse width for I2C. And if you are using SPI communication, this is master in, slave out, master out, slave in pin, and this is a serial clock pin. For the digital, we get 16 pins available, even more than actual Arduino Uno. And number of analog is also more. There are some limitations. For example, you do not get here 3.3 volts out if you get a 5 volts version, and for other purposes it will not be available. But this is the tiniest Arduino that you could get ever. There is a talk about Pico, Arduino Pico and Kickstarter, but still it's not available widely for people to buy. So this is the smallest one with tons of capability, with built-in USB, very easy to use and connect. This module, pin 13, is missing because for pin 13 we needed an LED, separate LED to blink. So they have removed pin 13. Keep that in mind. Click on File, Examples, Basic, Blink. This variable, the built-in variable in Arduino IDE, LED underscore built-in, will not function because in this one we don't have pin 13. So you have to type your own pin here, let's say pin 5 or 6 or whatever you want, but pin 13 is missing in this module. When you purchase it, it will be shipped like this with these pin headers. You have to solder it, and first insert one of the pin headers so it can hold it for you. Insert this here. This will look fine, and I want the pin to be down, so I'm gonna insert it here. This module comes with a bootloader already, so I will not go through the bootloading. I will just explain the device and how to use it. Do not worry about the chip, because only one manufacturer is making this. This is ATMEL, and everybody else is just using the same design that is open source and available. They just produce it, and the quality will be determined by the PCB quality. Other than that, in terms of electronic functionality, it will be the same, and it will be much cheaper. For example, this has been purchased from eBay or AliExpress, and if I zoom in, you will see that these are very clear print and this is not clear, so that will not affect the functionality of this board. And also the voltage regulator that are used are common. The crystal oscillator here, this is a crystal that is 16 megahertz in this case, and you can get 3.3 volts version of this in case if your system works with 3.3 volts. And these connectors are also not that critical in terms of quality, but one thing that I was worried is that this has been soldered directly on PCB, and they have not used a through hole pen here. This should have been out and soldered this way. This would have been very tight, so when you are using it, make sure that every time you connect it, hold this and remove it, and because if you juggle it, it might slowly loosen this and this will fall. Other than that, it's much better than using Arduino Uno. Of course, Arduino Uno has advantages, and because you can get 3.3 volts and 5 volts, and you can get also some shields available. But if you're not in need of those things, this is a very good alternative to Arduino Uno. It can be powered either via USB. You can connect it from battery or other sources, just power it up with USB or power adapter, or you can connect it with external power up to 16 volts to this pin. This is called raw pin, and it goes to the regulator, and then the regulator, this is 5 volts. You can get the same module with 3.3 volts regulator here, so when you connect either 5 volts, it will regulate it to 3.3 volts, and the pin 4, which is VCC, you will get the voltage that is determined by the regulator, so 3.3 volts. Or if you connect 16 or 12 volts or 9 volts, 7 volts, whatever voltage up to 16 volts that you connect, it will go through the regulator, and you will get the regulated voltage of the regulator at this pin, which would be either 3.3 or 5 volts based on your module. And then I'm going to test a servo using pulse modulation to control the position of the servo, just for test purpose. Length of the module, including the connector, is 33.8 millimeters. The width is 17.8 millimeters. Now let's see, when we connect this for the first time, let's see what windows pop-up show. I did not see any pop-up. Right click on your start menu and go to device manager. If you're using older windows, just type DEV, type device, and you will see it. And now under the port, you will see Arduino Micro automatically if you have previous windows. If you don't have it, I'll provide you the link to download. There is a jumper called J1, also shown in this diagram. To understand the jumper, here is how it works. This is the USB VCC. When you connect the USB, the 5 volts will come here, and we have a fuse here, 500 milliampere, and this is the regulator that uses by spark fan. So spark fan uses MIC5219, but the module that you purchase from eBay, AliExpress and other sources might not have the same chip. This is the limitation that they set. The input can be up to 16 volts. Here at raw you can connect 16 volts DC and 500 milliampere the output, but my test showed that it cannot even handle 200 milliampere. It will be heating up. We have raw, and then the fourth pin is a VCC, and the USB comes here. This is the jumper. In your Arduino you have raw, VCC. You don't have access to this USB VCC. This is coming through the cable. When you short circuit this, when you put solder between these 2 points, what happens is that the USB VCC will come directly and will be available at VCC. So this will be short circuited and it will not go through this regulator. And here is a diode. The job of this diode is, in case if you have USB or something, if you connect your external power, let's say 12 volts, this will not go because the diode will block it. You are very safe to connect 12 volts, or in this case up to 16 volts at raw, and the cable is connected to your computer. So it is safe here because we have a diode here, and the regulator will regulate it, and the VCC will always have 5 volts here. The regulator will not allow any higher voltage. Either the 5 volts will come here, the 12 will come and regulate it to 5 volts, and you will have it depending, or if you have 3 volts, 3.3, you will have 3.3 volts, or you will have always 5 volts from your USB, which will come this way if you solder it. If you don't solder it, still we have a little drop here and 14 millivolts here, 0.2 to 0.7 millivolts drop depending on the diode. You will have it here. So you will not have problem if you connect a raw and this is soldered and USB is connected. See what happens. If this is soldered, the USB will come here, and if you connect your own let's say 12 volts, you will get 5 volts, and that 5 volts will come here. If there is some discrepancy between this 5 volts and that 5 volts, if this is higher, we have some current will go here, and we have a protection which will protect it, but still there will be waste at that time. The problem comes regardless if this is connected or not. If you connect USB and your raw input is less than 5 volts, then we have problem. What happens is, let's say if this is 4 volts and input of USB is 5 volts, then the current will go here through your raw input because this is lower potential, and with the exception of a little drop from this diode, everything will be like short circuited. If the difference is 2 volts, it's like 2 volts short circuit, and the only limiter is this fuse. So that there will be a lot of waste and heat, or maybe this if this diode cannot handle 500 milliampere, this will burn. Make sure that when you connect your raw, always have 5 volts or higher. Because many people are struggling with understanding the power, as you can see here, we have here a VCC, 2 ground here, 1 ground here at this point, and 2 ground here, and there is a pin called raw. When you connect this to USB, USB always has 5 volts, and the chip will operate with 5 volts. But there is a voltage regulator here. When this is labeled as 5 volts, we get 5 volts here. So this will be in operation when you connect a raw. You can connect up to 12 volts here from your power. Let's say you have 7 volts, 9 volts, up to 12 volts. You can connect it here. This goes through this regulator and regulates 5 volts. And at VCC, we will get 5 volts. I'm going to show you now here. And I have 8.9 volts. I have voltage regulator here. Now it's at 11.3 volts. So we have 11.3 volts here. Make sure the positive you connect, make sure to connect the positive to the last pin. I'm inserting it here. That pin is connected to this. So the next one, ground, will be connected in here. Once you connect it, you will have, I'll get one ground here from the third pin. This is the ground, and VCC, as you can see in this diagram, is the fourth pin from the right. And here I just leave one pin empty. Now let's connect this voltmeter. One pin to that one, and the other pin to the ground. And as you can see, we are getting 5 volts at this point. So I've connected here 12 volts and the circuit is getting 5 volts. The circuit has 5 volts, and also this pin, the fourth pin from the right, has 5 volts output in case if you need it for your display for other devices. But keep in mind that the amount of current that you're getting is very limited. This is not like Arduino Uno or bigger boards. Now let's just upload a simple blink code from Arduino and make this LED blink. I'm going to connect this to pin 9. I'm going to define pin 9 here. One pin is connected to the resistor, which goes to pin 9, and the other pin will go to the ground, and the longer pin of this LED is connected this side to the resistor. The third pin from the left first thing, go to File, Examples, Basic, and open the blink. Then this has a built-in function for pin 13. We don't have pin 13 for this. Anywhere that you see LED built-in, change it, let's say, to pin 9, because we are working pin 9. This one also, let's make it 9. And 9, because the 9 is connected. Then go to Tools and Boards. Scroll down until you see Arduino Genuino Micro. The word micro here is helping us. Select that, and then also select the COM port. You have to see Genuino Micro Arduino. So this is the pin. It's selected. Now let's just upload the code. Once the code is uploaded, you will see that this will blink. The communication will complete from this, and this will start blinking. But let's wait for this first to see the code is transferred successfully. When you see the blink, that means it's good. And this is 1 second on. As you can see, it's high. It says digital write pin 9 high. So this turns the LED on, and then we wait for 1 second, delay 1 second, and then digital write pin 9 low. This will turn it off after this 1 second, and then we wait for 1 second at off state. And then because the loop comes from here to here, it goes back. For introduction to Arduino code, you can visit the link below to my videos. Let's change this to 2 seconds and make this 3 seconds. Now this will turn off for 3 seconds and turn on for 2 seconds. Let's check the pulse width modulation pin. These red are pulse width modulation. Pin 9 is pulse width modulation, and we're going to fade this from brightest to the darkest. To File, Example, and this time open Fade. Now it's already set pin 9. Everything is good. Let's just upload it. Completed. Now let's see. Yes, it's really bright in. Perfect. And now let's connect the servo. Now let's connect the servo, and instead of fading, let's rotate this a different direction. For that, I'm connecting, this one needs 5 volts, connecting from pin 4 and here, connect it to the middle, and then from this connect it to the ground, and then pin 9, which was going to LED, let's connect it to the orange pin here. This orange is for the signal. Okay, as you can see now it's blinking and this cannot supply. I was touching the regulator and the amount of current that this draws this cannot handle it, and it was getting very hot when I touched it. So what I would do is, I will not connect the servo. Let me reduce it to 5 volts. Now I have now the input voltages. Now I've changed the input voltage. When I connected directly to 5 volts, the chip got very hot. So I changed the input voltage. Now that is coming here is 5 volts. Now I can connect the servo, the middle wire of the servo directly to 5 volts here. And the 5 volt is this pin. I have room here. So my power supply is supplying it without going through this. I'm getting 5 volts directly from my power supply to this. And ground is connected. Now let's connect this to the servo. Now it's running perfectly. So it goes up to 200 milliampere, and this device cannot handle 200 milliampere maximum. Thank you for watching. This was the introduction to Arduino Pro Micro chip. If you like this video and learned something, please thumb up. Don't forget to subscribe so you can get updates of my upcoming videos.